Morning students. So today we are going to discuss exercise 1.6 lecture 3 number system. So in this section we are going to extend the laws of exponents which we had studied in class 8 also, about the exponents and powers and some laws related to it. Okay, so this time we are extending that law for the real number. So in class 8 we studied only on natural numbers. Okay, so both are almost same, only the extension has been done here. So let's see in this extension class 9. Let a be greater than 0, b a real number. We were studying there in class 8 natural number. Here we are studying about real number. So let a is greater than 0, b a real number, and m comma n are any two rational numbers. We were studying there integers only. So now integers has been extended to rational numbers. So m and n are what? Any rational numbers. Then we have the following rules. So the rule number first, a raised to the power n into a raised to the power n. This is into means multiply, equals to a raised to the power m plus n. So we see that both here a is called base and m is called exponent. We also studied this thing. A is base, m is exponent. So we see that both are a, that is we can say base is same and exponent are different. So under this property, this states that a, that is same base, will come and the power can be added if it is a product. So this product symbol converted into positive. This is the property first. Second, a raised to the power m divided by a raised to the power n. So here also a or a, we notice base are same and the exponent are different. That is here multiplying and here we are using division. So in division the powers can be subtracted. Okay, this is property second. Now property third. Look at a raised to the power n to the power n. So here a to the power n to the whole power n, that is there are double powers. So in this law these exponents, that is powers, can be calculated as product, that is a raised to the power n into n. These powers or exponent would be multiplied, okay, by this property. Rule 4, a to the power n and b to the power n. It's like property first, but there is a difference. Here same base and power different, that is exponent, and here is same exponent and base is different, that is a and b. Two different bases are there. So what we write, a into b, and this exponent m could be operated on both of the numbers together, that is this will be a into b to the power m. Now the fifth rule states a raised to the power minus n. Okay, n is what? Any rational number. So this will be 1 upon a raised to the power n. That is if n is here positive rational number, because it may be negative. Negative numbers are also rational numbers. So here the restriction is what? N is positive rational number. So minus n. So this will be 1 upon this minus converted into positive a to the power n. Clear? So this is called the laws of exponents. On the basis of all these properties we will be using in the questions. Now one more rule is also there. Also, let a be greater than 0, b are real number, and let m and n are integers. In previously we have taken rational numbers, now we are taking integers in this property, such that m and n have no common factors other than 1. That is m or n are what? Co-prime numbers, because m and n having only what? Common factor 1. There is no other common factor. Okay, it means what are co-primes. And n greater than 0. N is what? Any positive integer. So then we have this rule, a raised to the power m by n equals to, we can write m into 1 by n. Okay, this m by n is written as m into 1 by n equals to, or this 1 by n, see this 1 by n is written as nth root of a raised to the power m. This m will be the power of a to the power m, or this 1 by n be transported where as a root, nth root of a raised to the power m. So this is a very important property because many questions are based upon that, which we will solve. So now let us use these laws in the exercise problem. First, 64 to the power 1 by 2. Okay, so we are using what? 64 to the power 1 by 2. That is, I also like to add, if there is a raised to the power 1 by n, so we can write where n is positive integer, nth root of a. Okay, this should also be learned. A to the power 1 by n equals to nth root of a. So we are using this property, and this property is also the part of this. If we put m equals to 1, then we will get the same result. M equals to 1 because m is positive integer. So we can take m as 1 also. So 64 to the power 1 by 2. This is the first part. So using this property, this 1 by 2 is 2 or under root of 64. Using this property, 1 by n goes there as root. So this 2 will come here under root 64. And now root 64 is what? 8 into 8. We can write 64. So 2 power. So this is what? Simple square root. So we will take only 1 8. Okay, you studied in class 8 also, square root. Same as next, 1 by 3. So 3 will come here under root 25, 125. Factorize 125. This, and there is power 3, so we will make here 3, and which is 5 only. Okay, this is called cube root. So whatever root is there, we will consider the same pair. Now question number 2. Find 9 to the power 3 by 2. So we are using this rule, a to the power n by n. Still in previous part we have seen nth root of a to the power n. So this 9 raised to the power 3 by 2 is written as, this 2 will come here under root 9 to the power 3. We are using this property. Okay. So 9 to the power 3 means 3 times 9 into 9 into 9. Because there is power 2, so we will make 9 into 9. One pair will come, pair of this, only 9 will come, and this 9 is coming here. Now further this 9 is expressed 3 into 3, okay, and this 3 into 3, only 3 will come because there is 2, so square root, we write only 1, so 9 3s are 27, okay. Same as the next second part we can see 32 raised to the power 2 by 5. So using the same property, 5 will come here and root 32 to the power 2 times, and now factorize 32, so power 5. Now here is 5, so we'll make what pair of 5? 1 2 3 4 5, and we write only one number among these pairs, same as 2 for this and 2 2s are 4. Now the last question of the exercise and the chapter as well. Fourth part, 125 to the power minus 1 by 3. So this minus also we have seen the property, this will be positive by writing in the denominator, and this 1 by 3 will come here 3, then cube root 125, make pair and write 5. So here the question is just based upon strictly on properties, that is laws of exponent. So you have to learn the exponent first, only then you are able to solve. Okay. So you all need to go through the rule first. Question number 3, first part. 2 this and 2 power 1 by 5. So here base is same and power different. So using this property first, power can be added. So write 2 as it is and power is added. So take LCM 15, 10 plus 3, 13 by 15. This is the answer, right? Now the second part, let's solve one more part. Second, 1 by 3 to the power 3 to the power 7. So I have taken the different types of questions. Now equals to 1 upon, see, this 7 is the power of whole number, right? So 1 to the power 7 is only 1. So I have written only 1. And 3 rose to the power 3 to the power 7. It means 3 rose to the power 3 whole power 7. This power is operated on 1 as well as on this number separately, that is. Okay. And now 1 as it is. And power to power can be multiplied. This is also the rule. So 3 into 7. That is 1 upon 3 to the power 21. So hence this is the result. So I have discussed 2 parts. Now there are 2-3 more parts. So I hope you understood all these questions. So do practice the remaining parts and hence complete your chapter 1. Okay. And if you have any doubt, you can ask. Thank you very much.